screen. Can you see my screen?
Yes.
Okay, so hi everyone. My name is Pablo. I am based in Dublin, Ireland. So it's actually 5 p.m. here. But that's okay. So today I'm going to talk about design patterns for Salesforce CI/CD. So I was saying earlier, this was actually a presentation that I did at Dreamforce this year, and it was super popular, which only speaks about the topic, right? That the topic is popular. What I mean by that is that it was really literally full. That the room was full and like 50 people were left outside. So many people came to me after the event to tell me, hey, I couldn't make it. The queue was crazy. So after that, I decided to present it a few more times. And I spoke to the previous group leader, and he asked me to present here as well. Now, you'll see the name Salto referenced in the slides. This presentation is not about Salto. Salto is my employer. It is a little bit relevant to the conversation, but don't worry, this is not an ad. I'm not trying to sell anything. This is really about Salesforce CI/CD. I'm going to skip that. So the agenda for today is, first of all, this is an advanced topic. So I'm not going to be explaining what is Git or what is a sandbox or different types of sandboxes. I assume that you already know good amount of that, and potentially you have done some CI/CD. What we're going to cover here first is a little bit of mandatory history on CI/CD, where it came from. Then we're going to talk about the principles for creating what I call a Salesforce deployment pipeline. And we're going to see a full demo and a lot of code on how to do this with GitHub Actions. And at the end of the presentation, we'll see that there's a lot of patterns that emerge when we start doing this. And that's kind of the purpose of this presentation, is that sometimes we do a lot of different things with CI/CD, but we don't realize that some of these solutions are patterns. They can be reused in different contexts. And that's what I hope to teach today. Another thing is, I would like to make this as dynamic as possible. I don't want it to be a death by Zoom where I speak for 1 hour and nobody says anything. So please ask questions. I don't know. I forgot your name, Walter. Sorry, I don't know if you're okay, but like if you can tell me if people are asking questions on the chat, because I won't be able to see it, or maybe I can if I move this.
I'll monitor chat and I'll throw up the questions for you, Pablo.
Yeah,
That
cool.
way you can
And
concentrate on your content.
yeah, great. All right, so let's get started. So let's start with the CI of CI/CD, which stands for continuous integration. So to understand what continuous integration is, we first need to understand the problems that it is meant to solve. So initially, combining the work of multiple developers is hard, right? Unless you're a solo developer, likely you have other developers and you're working on overlapping code. And in traditional software development, developers have adopted Git branches in order to isolate their work. And in the Salesforce world, we use both Git branches and sandboxes, right? If you think about it, a personal or like a dev sandbox is kind of branch in the sense that it is an isolated environment. So regardless if it's a branch or a sandbox, the problem is that merging that work, combining it, is actually very hard. And this is because the longer that these branches exist, again, whether they are sandboxes or Git branches, the more they diverge from each other. They become almost completely different versions of a software, or in this case, a Salesforce org. And so then this leads to a lot of problems. Your releases are complicated because you have to account for the time merging all the code, and it just becomes a very unpredictable process. So then continuous integration emerged to solve these problems, and we can define it as a software development practice where the developers of a team integrate the changes that they're doing as frequently as possible, even multiple times a day, into a common branch of a version control repository. And the idea of continuous integration is that every time you commit that piece of work, that tiny change, there's a process that runs some automated build, and it runs all tests, and it gives you very simple feedback: pass or fail. Meaning, did you break the application, or does your code work well along with the existing code? That is the gist of continuous integration. Now, in reality, continuous integration is actually very hard because for this to work, you need to be committing multiple times a day or as frequently as possible. And if you think about it in the Salesforce world, we usually commit or we deploy to another sandbox when we are done, right? We commit or deploy once we have all the page layouts, all the fields, all the Apex classes. And it's kind of unnatural to think of deploying or committing changes that are not complete. So for most developers, this is a paradigm shift, right? How can I deploy or commit changes to a shared repository if those changes are not complete? And so this opens up a whole can of worms, and there's a lot of practices to get around this problem, such as branch by abstraction or feature flags, which is not something that I'm going to talk about today, but just to make the point that it does require a different way of working to do it correctly. The second challenge with continuous integration is that, as I said, the idea is that you commit, some tests are run, and you get a result pass or fail. That assumes that your tests are actually good and that they're fast. And in most Salesforce orgs that I've worked, the tests can take even 1 hour to run or even more. And especially if multiple developers are trying to run all tests all the time, it just becomes impossible. So then again, in the Salesforce world, it's actually hard to achieve real continuous integration because not every team is able to run all tests that frequently. So this is not to say that continuous integration is not possible. I just want to paint the real picture that as it was originally defined, it's hard to apply that to the Salesforce world. Now we move on to the CD of CI/CD, which stands for continuous delivery. So I'm going to quote Jess Humble, who's the author and one of the people who came up with this concept. He's one of the authors of continuous delivery. And he mentions that continuous delivery is the ability to get changes of all types into production safely and quickly in a sustainable way. So in that sense, continuous delivery is not really something you do. It's not a technical capability. It's not a project that you do. Sometimes it is confused with continuous deployment, which is a whole different thing. But as I said, continuous delivery is really a set of principles. The first one being build quality in. And what that means is that you should try to fix bugs as soon as they are found and as close to their source as possible. The other principle is about working in small batches. And we saw this in the example of continuous integration. If we work in small batches, if we're committing frequently, we shorten that feedback loop so that we get feedback as soon as possible. The next principle of continuous delivery is to automate everything. And that just means let humans or people work on higher value add activities. And everything that can be automated, you should look into automating it. And of course, that includes deployments. And that's why many times when we talk about CI/CD, we start talking about automating deployments, automated static code analysis, etc. And it comes from this principle of trying to automate everything that can be automated. Finally, there's an element of continuous improvement. And what that means is, as I said, continuous delivery is not a project. It's not something that you are done with and then you say, okay, I did continuous delivery, now I do something else. It's really a practice, and there's an element of always questioning yourself, can I be doing things better? Okay, so one of the principles or concepts that emerge from the continuous delivery movement is the concept of a deployment pipeline. And I have found that this concept doesn't really translate too well in the way that we develop in Salesforce. So I modified it a bit and just renamed it as a Salesforce deployment pipeline. But really what it is an automated process that runs your Salesforce metadata through a series of steps, such as quality checks, static code analysis, tests, and eventually deployments. And this process fires in response to events in your version control repository where you have your Salesforce DX project. So the idea of a deployment pipeline is that as your metadata goes through these steps, right? Quality checks, tests, deployments to other sandboxes. As it goes through these steps, it increases the confidence that we have on our implementation, right? Once the test has been, once the feature story, for example, user story has gone automatically from your dev sandbox all the way to UAT, we have a lot more confidence in that. And so that's what they were going to talk about is kind of the patterns for creating the Salesforce deployment pipeline. Very important that these are patterns, they're not mandates. So I'll be not really recommending what to do. I may give some guidelines here and there, but the idea is also that you come out of this presentation with maybe a few more questions than answers. But that's a good thing because those are questions that you can go back to your team and try to answer. And eventually you should do whatever works for you. Just gonna take a pause there and see if there are any questions. No? Okay. So let's move on. So the first principle is about choosing a sandbox strategy, right? So we know a sandbox strategy is a way to logically organize your sandboxes. So there are different things to consider here. Should every developer have their own sandbox? Or is there a scenario where you should be using a shared sandbox for all developers? And I know people get very passionate about this, right? Some people will say, oh no, you have to use your own sandbox. Or some people say, well, for some projects, you have to use a shared sandbox. As I said, there is no wrong or right answer. It depends on a lot of circumstances. For example, if you have a production org that is tied to a bunch of systems, right? It has a lot of integrations, a lot of endpoints, and you're always developing on those features, it's going to be actually very hard to replicate those integrations on every single developer sandbox. So it may make sense to have a shared sandbox, maybe only for those features that required, an integration with another system. So it's just one of those things to consider. You should also consider what type of sandboxes are you going to use for different types of testing. And if you're going to use developer sandboxes, you also need to consider how are they going to be populated with fake data. Another thing that you should consider in your sandbox strategy is how easily can you refresh your full sandbox, right? In one of my previous jobs, refreshing the full sandbox was a whole ritual of like 4 days because you had to first refresh it. And then we had this gigantic checklist of things to do, like, masking email addresses, remove integration endpoints, authorize organization-wide email addresses. So if we go back to that concept of continuous delivery, one of the principles was to automate everything that can be automated, right? So is there an opportunity here to automate some of those post-refresh activities? So here's a typical sandbox strategy where every developer has their own sandbox. And in between their sandbox and production, there's a sandbox in the middle, which could be the integration or QA sandbox. And this goes back to that concept of continuous integration, as I said, where every developer is supposed to merge their changes into a common branch. In this case, the branch is tied to an integration sandbox. And the idea is that this sandbox is used to run all tests every time a deployment is made to give feedback to the developer about whether their changes are working along with everyone else's changes. The next principle is very important and is about choosing which metadata to track. So at the core of CI/CD is having your Salesforce DX project in Git, right? And so there's a few things to consider here. Should we only track code-based metadata like Apex classes, Lightning Web Components, Visualforce pages? What about other stuff like custom fields, validation rules? Should we track those? Also, what about changes that we make directly in production? And again, I know that sounds like a horrible thing to say, but some companies do make some changes in production, and some changes are okay to be made in production. Like, again, in a gigantic org or a really large company, you may have business users who have been authorized to make changes to email templates, maybe changing some very specific custom objects that are used for, or custom object records, like CPQ records that are used for driving logic somewhere else. And so those are changes that you're making directly in production, and you need to think about how does that fit into your CI/CD strategy. Maybe it doesn't. Maybe you are okay with not tracking those changes. But the point is that it should be a conscious decision that you need to think about. Next is that the more you track in Git, the more metadata types you're tracking, then the more you need to know about the Salesforce metadata API. Because sometimes there's a lot of quirks to Salesforce metadata, like profiles behave very weirdly sometimes, page layouts as well. Flows can be very overwhelming to understand in XML. So the more you track in Git, then the more overhead um, you get about understanding the API. What I would recommend is that you ask yourselves which metadata types, if version in Git, is going to make our releases better. That's it. It's really about making that release process better. So if putting email templates in Git is actually going to slow down your release process, then maybe that's an indication that you shouldn't be tracking email templates in Git. But again, this is a question that you have to answer for yourself. Okay, the next principle is about choosing a Git branching strategy. And I'm worried that everyone is too quiet. Like, I really want some questions. Otherwise, I feel like I'm going to be talking to myself in this room. So are there really no questions, no comments?
Yeah, I think a lot of what you're covering now, like you said, is the theories here. We've got a lot of advanced people in the group.
All right,
I think questions are going to come up when you start getting into your showing the code and stuff like that.
cool. All right, so choosing a branching strategy. So the Git branching strategy is closely aligned to your to your Sandbox strategy. So things to consider is, do we create one branch per Salesforce org, right? If we go back to,
We do have one question that just came in
yeah, go for it.
from many. It said, "Can everything and every metadata be tracked?"
No, there's an article in Help and Training that lists. Actually, no, there's even one better. So let me actually bring it up on the screen. There is the Salesforce metadata coverage report, which basically tells you which metadata types are available in the metadata API, which means that they can be retrieved and deployed. So this is the page. So you can filter here by metadata type as well. And so essentially you can just sort by this. And so all of these cannot be tracked in Git because they cannot be retrieved. They're a little bit uncommon. Like, to be honest with you, I don't know some of these. Like, I don't know what a data pipeline is. It must be something with, Tableau CRM or something like that. But there's a few here that you cannot track. So if your org is using some of these, then their metadata just cannot be tracked in Git. Which then raises a very important topic, which is, can Git really be your source of truth, right? And that's a question I get a lot. How can I make Git my source of truth? And I usually reply, well, what truth? Because first, as I said, you cannot track everything. And even if you could, your Salesforce org is more than just metadata. Many Salesforce orgs have managed packages that have configuration data. Like, if any of you know CPQ, CPQ is actually configured by creating records of custom objects, right? Like, you have pricing rules and price conditions and automations and things like that. And those cannot be tracked natively in Git, or at least not with the metadata API. So what you have in Git is almost always a partial view of what's in your org. So it can be the source of truth of the changes you've made to some metadata types, but I would argue that it cannot really be the source of truth of the state of what's exactly in the org and in which state, if that makes sense. So anyway, go to the metadata coverage report to see what can be tracked. All right. So then the Git branching strategy, right? Things to consider is, do we create one branch per Salesforce org? If we go back to the example earlier of the Salesforce, Sandbox strategy, we had, for example, integration sandbox, UAT, and production. So some companies will have one branch per Salesforce org, like one integration branch, one UAT branch, and one production branch. And that may work. Maybe there are other scenarios where you can have just one branch, which is usually known as strong base development. And what that means is you just have one branch. And the school of thought here is that your sandboxes are already kind of like branches. And it kind of makes sense if you think about it. Again, sandboxes are Salesforce's native way to allow for isolated work. Um, so some people like to treat sandboxes as branches. And so rather than having more branches in Git, they just have one. They commit to that branch, and there's an automated process that deploys that branch to all the other sandboxes. It has some disadvantages. There are also some advantages. For example, if you deploy from the same branch, then you know that all of your orgs have, the same metadata. Some disadvantages could be if there's metadata that has to be different on a Salesforce org, like email addresses and things like that, then it doesn't work too well. Another thing you should consider for your branching strategy is, how do we deploy to production? Are we deploying when we do a push to master, or is it when we do something else? So we need to think about that. And we'll see an example of that later. My recommendation is to have short-lived branches. Again, if we go back to one of the challenges that led to the rise of continuous integration, was the idea of long-lived branches. The more your branches live or exist, the more they'll diverge and the harder it is to eventually merge them. So here's a typical branching strategy that is very common in Salesforce. This is called Git flow. So basically you have a main branch which represents production. At the beginning of a sprint, you create a development branch, and then developers add or create feature branches off of development and merge them back into development. And then at the end of the sprint, you merge development back into main, and that triggers a production deployment, which we'll see later on. Okay, the next step or principle is about choosing a continuous integration server. So when I started learning CI/CD, this was very hard for me to understand exactly what a continuous integration server is. And so the easiest way to explain it is, when you're running Salesforce DX commands on your computer, right, like SFDX, push or pull or deploy, you're literally typing that in, right? And if I asked you, can you make sure that those commands run later at 5 p.m., how would you do that, right? Would you leave your computer on, make sure that it's connected to the internet at 5 p.m. so that those commands can run? That wouldn't make sense. So what a CI server can do, among many other things, is it can create a virtual machine for you on demand. And then that virtual machine can do a few things. First, it can connect to your Git repository where you have your SFDX project, and it can download that project into its local file system. Then the virtual machine or the CI server can respond to events in your version control system. Again, if you're doing push or maybe creating pull requests. And in response to those events, the CI server can then execute commands on the terminal of that virtual machine that was created automatically for you. And those commands are the same commands that you would run manually yourself, right? Like SFDX commands or bash or node. So essentially the CI server is used to automate deployments using SFDX by having your SFDX project stored in a version control repository. So some of the typical CI servers include GitHub Actions, which is what we're going to do today, Azure DevOps, Bitbucket Pipelines, and a few others. Okay, so this is the most important part of the presentation. So it's about deciding what to automate and when. So what I recommend is that if you're starting to implement CI/CD, you get with your team and just have a conversation about what you want to automate. And you don't necessarily need to know how you're going to automate that or when. just think, what are the things that we want to do automatically? So let's say with my team, I decided that I want to automatically deploy metadata to the next sandbox in the pipeline. Again, I don't know how I'm going to do that or when. I just know that's something that we don't want to do manually. We don't want people creating chain sets and manually deploying to the next environment. Another thing that we want to do is we want to give the developer the ability to run the tests that they want to run. So do they want to run all tests when they deploy, or do they want to run just certain tests? And we also want that to be as automated as possible. Also, let's say that we also want to scan the code. So we want to use PMD or the Salesforce DX scanner to automatically scan the code because we don't want people to be doing that manually. Finally, we also want to do a delta deployment. And what that means is we only want to deploy the metadata that has changed. And what I mean by that is that traditionally in CI/CD, you deploy the entire branch. You're essentially deploying the entire SFDX project to a Salesforce org. And there are some scenarios where you may not want to do that, right? Maybe you're just making a small change and there's no reason to deploy the entire branch again to a Salesforce sandbox. So let's say we also want to figure out what has changed, and we want that to be done automatically, and we want that to automatically be included in our deployment. So these are the things that I want to automate. The next step is to map those actions against events in your version control repository, which is what the CI server will be listening to, right? So let's say that when a pull request is open against the development branch, I want to figure out which metadata has changed. I want to do static code analysis. I want to do a check calling deployment against the integration sandbox. And I want to run the test specified by the developer. Let's say there's another event, which is when the pull request is approved and merged. I want to then do a full deployment to UAT. That means deploying the entire branch. And I want to run all tests. And likewise, when the development branch is later merged into master, I want to deploy the entire branch to production. So what I've done here is we've taken those actions that we knew we wanted to automate, and we have mapped them against events in our version control repository. And this is really our deployment pipeline. This is what really means to have a Salesforce deployment pipeline. And the case I'm trying to make in this presentation is that it's very easy to just jump and start configuring these things, right? Go into Git and start creating those branches or start creating those YAML files. But there's a lot of thought process behind those things that you should do consciously, right? Which metadata am I going to track? How many sandboxes I'm going to have and why? Am I going to have one branch per sandbox, or can I use a different branching model? So all those things are the patterns that we'll see later, how we can group them into logical groups. Okay, so that's enough talk. So let's see a demo. Are there any questions in the meantime? Okay, no questions. All right, so the first demo is, oops, where is this? Is how to set it up, and then we're going to see a demo of how to actually use it, meaning what's the developer workflow. So the first step, as I said earlier, is choosing which metadata to track. So what I'm going to do here is I have my SFDX project, and here's the package XML. This is where I can choose what metadata I want to track. So what I'm going to do here is I'm going to connect this to my Salesforce, my dev sandbox. And then I'm going to use this Visual Studio Code extension, which is really cool, that allows me to scan the org that is connected in Visual Studio Code, and then choose which metadata types or which metadata components I want to track in that package XML. And that's that exercise, right, of making that conscious decision about what we want to track. Let's say in this case, I decided to go with the default. I'm going to just have all the code-based metadata. The next step is then to retrieve that, which is going to obviously retrieve all that metadata into my local file system, which we can now see right here. The next step, again, this is all about setting it up the first time. The next step is to upload the entire SFDX project to GitHub. So we're going to initialize this as a Git repository. We're just going to do a Git commit saying, this is the first initial snapshot. We're going to go to GitHub, create a repository, and then just paste the instructions and throw them there. Then if we go back to GitHub and we refresh, we'll see that our entire SFDX project is now on GitHub, just like that. The next step is to get the authorization URL for each sandbox and store them as environment variables in GitHub. So I'm going to use this sfdx command, which is going to generate an authorization URL for me. And this allows my CI server, in this case GitHub Actions, to connect to that sandbox. So I'm going to go to GitHub and I'm going to add this as a secret. And I would need to do this for all the sandboxes in the pipeline. So in this case, let's assume that this is UAT. So I just throw that URL in there and I add it. And I would do the same for production and all the other sandboxes. So the next step, I'm going to show it actually then manually. So after you've done that, right, the next step is to actually create the configuration for the pipeline. And that's typically done in YAML. So I have here a group of YAML files for that. So for each CI server, this is different. I really like the way GitHub Actions work, just because I find it a lot more intuitive than the other ones. But at a high level, this is the file that is going to execute when a pull request is open against the development branch. And this is when we start doing those things like automatically creating a virtual machine, right? Using, in this case, let's say Ubuntu as the operating system. And we start setting up that virtual machine. Like, okay, I want Node.js version 14. Then I want to download the SFDX project into the local file system of this virtual machine. And then I want to do a few more things. Like, for example, I want to install the Salesforce CLI, install SFDX Git Delta, Java, the SFDX scanner. And again, the concept here is that you could do all this stuff manually on your computer, but you don't want. You want this to be done automatically when something happens in your version control repository. So the first step is to start populating here kind of the setup for that virtual machine. And then at the end is where you can actually start doing things like, okay, I want to then use the Salesforce DX CLI to deploy only the metadata that has changed as a check-only deployment. Now, there's a lot of overhead in creating this because, as you can see, I also have some Bash and I have some Node.js files, and I need to know a lot about the configuration specific to GitHub Actions. So for this presentation, or for the original one at Dreamforce, I created a new free and open source tool called Naki, which stands for Not Another CI Tool.
Somebody just stated they can see the metadata cover screen. Are you trying to show another screen? That was a couple minutes ago.
And what screen did you see when I was like, I've been.
No, now it's better. No shows.
Okay, it's caught up then. All right, thank you.
So were you seeing, I was showing the Visual Studio Code here. Is that what you saw? Most people?
Yes.
Okay, well, I'll assume that most were able to see what I was showing here. So what I was saying is that creating this pipeline is actually very complicated. So I created this new tool called Naki. You can find it at ci.salto.io. It's free and open source. And it basically will walk you through that thought process that we saw earlier, right? About thinking about your branching strategy, the sandboxes and all that. And it's going to create the pipeline automatically for you. So at this time, it only supports GitHub Actions, but I plan to add more CI servers. But let's say that you go here and you say, okay, I want to create a pipeline with GitHub Actions. So you choose that. Then I ask you, what's the name of this job? Maybe you want to deploy to UAT. Maybe it's a validation deployment. So let's call it validation to int sandbox, for example. Next step is I ask you, how are you going to authenticate to that sandbox? Are you going to use the SFDX URL or are you going to use the JSON Web Token flow? Let's say in this case, I choose the SFDX URL. Then I will need to go to GitHub, create that secret, and then come back here and just give the name of the secret. I'm not asking for the actual URL, just the name of the secret that you created. So let's say here it's called UAT login URL. And then here's when we start thinking about the pipeline, right? What do I want to automate against this UAT org? Well, let's say I want to automate a validation deployment. Okay, and what type of deployment is that? Do you want to deploy the entire SFDX project or just the Delta, meaning only that which has changed? So let's say just Delta. And then we need to, again, map that against something that is happening in our version control repository. So let's say I want this to happen when a pull request is open against the development branch. I could also specify other branches here. Let's say against the UAT branch, right? So when somebody opens a pull request against UAT, I want to automatically deploy that which has changed to that org. Finally, I can also say if I want to run all tests or do I want to give the developer the ability to run all tests, and I'll show you a trick on how to do this. And finally, I can also say, do I want to do some static code analysis, right? Like maybe I want to use the SFDX scanner to check the design, code style, and security. Once you're done, you just click on create pipeline, and just like that, the tool will generate the entire YAML file for you. And this works. This is the one that I'm using right now. And I've had a lot of people use this and they've told me that it just works pretty well. So hopefully you find that useful. And in the future, I will add support for other CI servers. So once you have the entire YAML file, then you go to your SFDX project and you add it there under the GitHub workflows directory. And that's it for your setup. Next, I'll show you how to actually use it. So see if there are any questions. No questions. Okay. So let me then go back to see how do we actually use this thing. So the idea is that at the beginning of a sprint, let's say the release manager creates a development branch from main, right? This is going to last only for this 2 weeks sprint. Then every developer is going to go to their sandbox to the Visual Studio Code and do a git fetch to get that branch. And the next step is to then create a feature branch against that branch. So here I'm going to create a new feature branch. And I'm going to choose the development branch as the origin or source branch. So once I've done this, then I can actually start doing, the actual development. I'll create a new method. I'll do a few things. I'll deploy to my sandbox. There's no CI/CD here, right? I'm just deploying from Visual Studio Code directly to my personal sandbox. We'll do that automated deployment later. And this step does, or it makes sense for it to be manual. So again, I'm deploying this test to my sandbox, and then I'm going to run it to make sure that all the tests are passing. They are passing, so great. Now the next step is to actually commit this. So I'm going to do simple git commands like git add, git commit, and I'm going to add a commit message. And then the next step is to push this branch to the remote repository, the entire branch. So once the branch is in the remote repository, we are now ready to create a pull request against the development branch, right? And then here we can add some details, like we can add a description of what has changed, right? Let's say I created a new method. So I can, and someone is not muted, and there's a bit of background noise there. Yeah, thanks. So the other thing that I said earlier that I wanted to do is I wanted to give the developers the freedom to choose which Apex classes to run tests for. So in this case, I'm going to take my class, the Dreamforce class test. I'm going to take that name and I'm going to add it here directly on the pull request. And I'll show you how I can pass this to the Salesforce CLI so that it only runs this test. Then here I can see all the changes that I've made. And now I can create that pull request. So now that the pull request is created, this is when our first piece of automation starts to run, right? Remember, we said when a pull request is open against a development branch, we want to do a check-only deployment against the integration sandbox. So what we see here is GitHub Actions basically creating that virtual machine for you, installing all the dependencies, all the different packages so that it looks like your computer, so that it can run SFDX commands against the integration sandbox. So it has done that. So now if I go here to my integration sandbox, I can see that there is a validation deployment that succeeded. And I can see that only 2 test methods were run, and that's because I only specified one class in the pull request. I can also go here and zoom in, and I can see that indeed only that class was run. Again, I'll show you later how I did that. Another thing that we wanted to do was we wanted to automatically scan the code, right, when we did a pull request. So if I expand this here, I can see that there's also a result for code scanning, and there are 2 alerts. So if I click on details here, I can see directly in the GitHub UI, what are those alerts generated by the Salesforce DX scanner. So here is basically telling me that I didn't include a third parameter on the system assert method. And I can also click on the code to see exactly where that, or where's that piece of code that the alert is complaining about. Let's say in this case, it doesn't matter, and I'm not going to change it because it's not really relevant. So I'm ready to merge this branch into the development branch. So I'm going to do a squash and merge, and then merge again. So now the feature branch has been merged onto the development branch, and this is when our second workflow has started. If we go here to the development branch, we'll see this icon here. That means that there's a new automation running here. And what's happening is now we're deploying the entire branch over to the UAT org. So if we go back to our UAT org, we'll see that now there's a full deployment that succeeded. It's no longer a validation. And here we can see that 3 tests were run because that's all the tests that I have in my org. Obviously, in a real org, you would have a lot more tests. So the point is every developer would be doing this, right? Every developer would be merging stuff into the development branch, which starts deploying to UAT. At the end of the sprint, all the changes from all the developers will be in the development branch. And when we're ready to deploy to production, we will create a pull request from the development branch against the main branch, which represents production. So I can include, again, some information here about what we're deploying. I can see all the commits, which represent all the different user stories, along with all the changes that were made. And then I can create a pull request. Let's say then the whole team reviews these changes. We're happy with them. There's no automation right now. The automation will kick in once we actually merge the pull request. Once we merge the development branch into main. So now that we've done that, the final and third automation has started, which is deploying the entire main branch to our production org. So again, we go to details here, and it's the same story. The virtual machine, doing all the dependencies, and doing the SFDX commands against the production org. We can see that it succeeded just there. And pretty much that's it. As you can see, everything really happened automatically. And one of the other things that I did here is I automatically created a release record. So this helps me keep an audit of all the releases that I've done to production. I can see a list of all the commits, which again, hopefully is 1 commit per user story. And I also have a zip file with the source code, meaning the entire SFDX project. And I can use this if I want to do a rollback or if I want to go back 4 releases and see what we were doing.
Pablo, another question just came in. What is the plugin used to identify the Delta changes, and where is it installed?
Yeah, we're going to look at that right now. Okay. All right, so how did I do some of these things, right? So how did I authenticate to the Salesforce org? As I said, I use the SFDX URL. I find this a lot more intuitive and just simpler than the other method, which is using the JSON Web Token flow. In that flow, you have to set up a connected app for all the sandboxes. And personally, I just find that very tedious. So you can just generate that URL as I showed you earlier. You put it as a secret in your CI server, and then you can use this SFDX command to authenticate against that org. Next is how did I allow the developer to specify which tests to run in the pull request, right? So if you remember the demo just now, the developer put the class name directly in the pull request in this syntax, and that was the only class that was run. So the way I'm doing this is I have a bit of Bash and Node.js in my pipeline file. And basically what I do is I take the whole body of the pull request and I dump it into a text file. And then I have a bit of Node.js that reads that file and it goes line by line and it checks if the pull request has that syntax, that specific syntax that I specified. And if it has, then it starts extracting the classes or whatever words are there. You could have multiple words separated by a comma. And once it has that, it puts that into an environment variable in GitHub. And then I use that when I call the sfdx deploy command. For generating only the metadata that has changed, I'm using this package or this Salesforce DX plugin called SFDX Git Delta. I highly recommend it. It's really, really good. It's open source. It's in GitHub. Basically, what you do is you create a directory where you're going to put the delta, and then you call that plugin. And basically, this is saying compare this commit to the previous commit and figure out what has changed between those commits, and then put those changes inside this folder. Then later, when I do the actual deployment, that's why I'm saying deploy from change sources Force app rather than deploying the entire Force app. I'm only deploying that which has changed. So hopefully that answers that question. Right, so there's a little bit of advertisement here about Salto. So I didn't say what Salto is, which is my employer. We are a DevOps platform. I know there are many DevOps platforms, but one of the things that is also important is to recognize when to use a DevOps platform, because I showed you essentially how you can do it all for free using open source tools, right? But there are some areas where you might start hitting some limits and it might make sense. So the first one is, as I said earlier, your Salesforce org in most cases is not just metadata. You may have some managed packages that use custom objects data for configuration. So if any of you are heavy users of CPQ, you know how many records you need in CPQ to configure, some bundles or some automation. And because that's metadata, you cannot really track it in Git. You cannot do validations with that. You cannot do CI/CD with that. So in Salto, we have a very unique approach to Salesforce metadata, and we can literally translate data into metadata, as crazy as that sounds. And we can include your CPQ data or any other reference data into your CI/CD pipeline. Another problem, as I said earlier, is that the more metadata you track in GitHub, the harder it is. And some metadata types can be very, very complex to read. If any of you have seen a flow is a gigantic file of XML, and looking at the diffs in GitHub or any other CI server is really hard. So in Salto, we actually put like a layer on top of that where you can see a flow as kind of like a Google Doc, right? You can see here all the elements that have changed in the flow, and that just reads a lot nicer than a bunch of XML. We also have a lot of tools for allowing developers and admins to collaborate together, so we can have the admins participate on pull requests without ever having to leave Salto or without knowing what Git is. And then we also have a lot of deployment validators that validate your metadata, and we can alert you of possible deployment errors before they happen. So anyway, so that's kind of how you set it up, the different principles that we saw, or steps or thought process for creating a Salesforce deployment pipeline. But again, if we step back from this, we realize that actually there are patterns to these things, and there's a way that we can group all these activities into certain categories. So when it comes to Sandbox strategy, right, you have different patterns, such as using a shared sandbox, having individual sandboxes, or maybe a hybrid approach where some projects use a shared sandbox, other projects use personal sandboxes. When it comes to source control, which is what do you actually have in Git, there's a pattern of tracking all metadata, which really makes Git almost your source of truth. Or maybe you can go for the easier pattern of just tracking the code-based metadata and leave admins and declarative customization out of that process. When it comes to branching strategies, there are different patterns such as Git flow, which is the one that I use. Also, there's a pattern of one branch per org. As I said, integration branch, UAT branch, production branch. And then there's a less used pattern of a single branch, which is similar to trunk-based development. When it comes to actual deployment, to do a deployment, there are two patterns. Either you deploy the entire branch, everything that's there, or you deploy only that which has changed. When to use each really depends on you. I would say if you're really trying to make Git your source of truth, you should try deploying the entire branch, right? You can think about it this way. If you did your last deployment 2 weeks ago, and I asked you, hey, can we deploy the entire branch again just now, just for fun? If that makes you nervous, that means that Git is not your source of truth, right? Because if it was, you wouldn't mind deploying that branch at any time, because you know that what's in your org is what should, or no, what should be in your org is what's in Git. When it comes to choosing continuous integration servers, there are also two patterns. One is to use a built-in integration server, continuous integration server. And what that means is what I did with GitHub Actions, right? I have GitHub as my hosted Git, and then GitHub Actions comes built in. And so I can use it very easily. The same applies to GitLab. They have GitLab CI and then Bitbucket pipelines. But you also have a pattern of choosing an external continuous integration server like Jenkins or Circle CI. When it comes to running tests at deployment time or validation time, very simple. You can either run all tests or run specific tests. People get also very passionate about this choice, right? Why should you not run all tests all the time? And I usually give the example that in my previous company, I used to work on, it was a very large team. We had CPQ, Financial Force, Service Cloud, Community Cloud. So I used to work on the Service Cloud area. And sometimes you were working on a Lightning component for Service Cloud, which had just one Apex class as the controller, and that's it. It's very close, very centralized piece of logic. So if you're making a change there, why would you run tests for CPQ or Financial Force, right? If that piece of Apex is never going to run in a trigger context because it is a controller for a Lightning Web Component, what's the point of running tests for CPQ or Financial Force, right? So again, I'm not saying there's no use case to run all tests, but there's a reason Salesforce gave us that option, right? So you should use it wisely. When it comes to the patterns for what your CI server should be listening to, right? When should those automations kick in? It can be when the branch is created, which is not what I did, but some people have a process run as soon as the feature branch is created. It could be when a pull request is created, maybe when the pull request is closed, or when you do a push. That's a typo. It should be when you do a push to a branch. And finally, when it comes to CI/CD solutions, the pattern is either you do it all yourself, like I did here, or when you start hitting limits, or if you don't have, the skills to really manage all these, or the time or resources, then maybe look for a third-party platform, again, like Salto or some of the others. So really, that's it. If you enjoyed this session, which I hope you did, I talk every week about CI/CD on LinkedIn. So I have this thing called CI/CD Weekly, and I just give different tips about CI/CD. Some of them come from this presentation. Others are other stuff that I couldn't fit into this presentation. So either you can follow me on LinkedIn or just follow the CICD weekly tag if you're.
Excellent. Well, thank you, Pablo. This was really good content. I'm wondering if everybody's over here is just getting ready for Thanksgiving, and that's why they're so quiet today. But this recording will be posted once it compiles and I get it downloaded. Probably going to be after Thanksgiving.
Yeah. I'm worried either everyone knows this stuff and this is the wrong audience, or I didn't make any